More and more, we will be able to measure and understand how our brain cells function. Deciphering our consciousness is another question. But the experiments of Dr. Yang Dan have proved that in principle, it is possible to read and to understand the brain.
I didn't know that we started this thing again. So this is a digitized movie. We present this to the animal, and we record the activity of their visual neurons. And these electrical signals that we recorded from will travel through these cables.
She managed to tap the vision from the brain of a cat and to reconstruct what the cat sees onto a computer screen.
So this is a digitized movie. This particular movie is a short clip from Indiana Jones, I think.
Here we see the two images next to each other. On the left, the image that was shown to the cat. At the right, the image that is tapped out of the cat's brain.
The picture has a lot of random flickering, the noise. That's probably the noise of the actual neurons, because they sometimes fire spontaneous spikes. We consider those noise, but maybe they reflect something else, maybe the thoughts or something. But we can't distinguish that. So when we use all of those, thinking that they represent visual information, this is the reconstruction that we come up with.
It is the first time an image was tapped from a brain. It proves that we can read and understand the grammar of it. The face is recognizable, but I still can't avoid the impression that the face has something cat-like.
So sleep is clearly very important. Not sleeping enough affects our ability to work, to learn, or even to drive safely. Sleep disturbances are linked to multiple psychiatric disorders, including depression, and long-term sleep deprivation causes other health problems, such as obesity and cardiovascular diseases. So the goal of my research team is to figure out the sleep circuits so that we can improve and perhaps even control sleep. We know that neurons function by firing these little electrical impulses called spikes, and it's the propagation of spikes in various brain networks that controls behavior. So if we can use light to control spiking of the sleep neurons, we can control whether the animal goes into sleep or wakes up. Our current work is mostly done in the mouse. For example, recently we studied a group of neurons in the medulla, which is part of the brainstem. What we found is that when we turn on light to activate these neurons, we can reliably convert non-REM sleep to REM sleep within a few seconds after we flip the light switch. So we think we can control precisely when the mouse starts dreaming. And in addition to controlling the spiking activity, we can also observe the activity. And because the sleep neurons are buried very deep in the brain, we insert a microendoscope into that brain region and attach a tiny camera to the head of the mouse. So here you're seeing flickering of the neurons, which reflects their spiking activity. And once we identify some of the sleep neurons, we also have the tools to map out their inputs and outputs of this very complex network. In other words, we can use the identified sleep neurons as a starting point to trace out this big network. This would allow us to figure out what goes wrong when someone develops a sleep disorder, so we can come up with effective strategies to repair the sleep circuit. Identifying the key elements of the sleep control mechanism might also allow us to apply external control of these elements to normalize sleep when the natural circuit malfunctions. At the moment, our technique for controlling mouse sleep is not yet applicable to humans because it involves injection of virus and insertion of optic fibers into the brain. But when safer techniques are developed for humans, we could potentially turn sleep on and off at will. So my question for the audience is, if that becomes possible, do we want sleep on demand? Thank you.